Okay.
Mm. Okay.
What's the inner function?
B sine x plus 1.
Yeah. Good. And the outer function?
And the outer function cos x.
No. Careful. Notice it's not, if the outer function was cos, it would have to be cos of this result.
Mm.
By the way, this is, don't forget, we're saying the result of that because it's a function. So this might begin to answer your earlier question about why do we care if there's two outputs. We want to be able to talk about the result of a function.
Right.
We want to know, you know, we are assuming here that we're just talking about one particular result of a function to put into cos here.
The power of something?
Sorry? Yeah.
Is it to the
power of?
-1?
-1, good. In which case the function up here must be?
Sine x.
The outer function, I mean. So the inner function is still blob is blob, yeah?
Yeah, it would be 1 over 0. It would be 0.
That's the problem, isn't it? It would be power of 0. And then if we check by differentiating, it doesn't matter what the coefficient was, 0 times coefficient would be 0.
Yeah.
So if you recall...
Yeah, we do that weird thing.
Was it up here? No, on a previous sheet. Had the open recent. Yeah. Was it that? No. With that. Not really. Hold on a minute, sorry. Ollie. Must be this one, surely. Oh no, maybe not. No, definitely not. Sorry. Yeah, there we are. Oh, God. Sorry, that's all I was trying to find. Remember these 5 basic ones?
Yeah.
This one, x to the -1, is the one that didn't work, isn't it?
Yeah. So what one do we use?
To integrate 1 over x?
Yeah. 1 over O. Right.
You see?
Well, how is that 1 over x? Isn't it just 0? How is the one we're doing 1 over x?
Well, it's 1 over blob. Blob to the -1.
Okay. Yeah.
I mean, that was your idea, and you were right to make that power -1 because sine x plus 1 is on the bottom there.
Yeah. Okay, I understand.
So the outer function up here, the outer function down here is 1 over, or power -1. The outer function up here must be?
Ln.
Ln, yeah. Oh, I used to hate saying ln. Or ln. I used to make saying natural log or log natural. but you can't beat and join him. Right. So, yeah.
And then that will differentiate to cos x.
Yeah.
And then we're basically, that's it, isn't it?
Yeah. No adjustments to make.
No.
A lot of these exercises have been about having to make appropriate adjustments. You know, it's not going to work straight away. But because we haven't, sorry?
Yeah, I was just saying, yeah.
I mean, they haven't, but this is a new kind in a way, so they're breaking us in easy. In that way. Right. Okay. Next. What have we got here?
Okay. I reckon blob will be sin x.
Yes, it must be. You might try it the other way round, but you'd find you would be in trouble when you tried to follow it through. But yes, sin x as blob is going to work.
And then if you go up,
yeah,
you'll get blob sin x. So blob sin x in the blob. I don't know. You like to draw the blob. It's easier in my head if I can see it.
Sure.
And then that's gonna differentiate to cos x.
Dan, that's right.
And then so you've got sin x times cos x.
What you forgot to think about really was what's the outer function?
The outer function.
Because this isn't just sin x times cos x, is it?
Oh, it's
sin x wrapped in
-1, to -1
to the power of -1 again, yeah. Which just for a change, you know, why not write? Oh, why not write it as 1 over?
Yeah. And then I guess we'll get same again, really. Ln sin x.
So it must be ln is the outer function up there. That's right. It's all done. So the answer is just log of sin x plus c. That's a kind of standard result, by the way, which will be in the list of derivatives in the formula booklet. I wouldn't claim it's one that I tend to remember. I have to check it out in this way quickly. It doesn't take too long. But even differentiating is a bit quicker. But the integral of cos over sine, which of course, what do we call it? Cos over sine.
We call that cot.
Yes, good. So it would help to know that the integral of cot is just log sine. Sounds a bit weird, actually. Log sine. No, that is right. Got it right, haven't we? That must be that on the bottom. Yeah. Yeah, it's fine. It's done. Right. What about sine over cos?
I guess we'll take cos as the blob.
Yes, for the same reason that it's got to have an outer function.
Yeah.
Which is what? The outer function is?
Minus to the minus 1.
Yeah. We've got 1 over blob, really, where blob is cos.
And then
So up here
on
we've
top
got,
you're going to get ln blob.
yeah.
And then you'll get minus sine
Yeah.
differentiated. And then you just times it by minus 1.
Yes.
Minus cos, yeah.
So yeah, minus there, minus there.
Yep.
We notice we could rewrite that. We do tend to rewrite that as log of what? Positive log of what? Because have you noticed that a negative log can always be rewritten as the log of what? For example, log to base 10 of 1,000 is
3.
Yes. What's minus? Well, obviously minus that would be minus that. That's true. Damn. But no, I can make my point, can't I? Log to base 10 of 1,000 is 3. Minus log to base 10 of 1,000 would be log to base 10 of what?
Minus.
I mean, minus. This is going to be minus 3, isn't it?
Yeah.
But minus 3 is going to be the power we have to raise 10 to get
minus 1,000.
Careful, no. If you raise 10 to the power of minus 3, what will you get?
Like 0.
Yes.
0.01.
In other words, 1 over
100.
1,000.
1,000, yeah.
In other words, the negative of a log is the log of the. I mean, let's take another example.
Yeah.
Sorry?
The log of the inverse.
Yeah, what kind of inverse in particular? You don't just mean any inverse. I mean, 1,000 became 1 over 1,000. What kind of inverse is that?
Reciprocal.
Yes. And you'll see that fits in with the log rules as well in practice. But remember it as just a fact, because it's useful, that minus log can be rewritten as log of the reciprocal. And the reciprocal of cos is?
The reciprocal of cos is sine. Minus sine.
It's sine is a close relative, sure. But if cos is perhaps the triangle, really just from the definition of, I mean, reciprocal means 1 over, doesn't it? That's what I'm getting at.
Yeah, yeah.
And what do we call 1 over cos? We just have a word for it, that's all.
1 over cos is cot
Is 1 over 10.
Sec.
Sec is the one, isn't it?
Yeah, I don't know why I didn't think of that.
I should put brackets around there, really, I suppose, to make it clearer. Yes, I will. So the integral of tan is log sec x is the standard one that you'll find in the, where was I? Here, formula book. The integral of tan is log sec.
Yeah.
Notice what these k's in here in the formula book. Until you're really confident with the chain rule, I disapprove of them putting the k's in there. But we should address that by looking at k multiples. Hopefully it'll become obvious with a bit more practice at this. So a bit more practice if you're all right with it. Let's do this. This is at least this is a bit different. I know it's a bit repetitive, but they're all.
No, I don't different.
Integral of all of that.
So I'm guessing the blob will be x squared plus x.
Yes, good guess. Yes, you are looking out for exactly the right thing. That'll solve it really. If we make blob x squared plus x
to the -1.
To the -1. I do prefer to put it as 1 over, so I wish I'd remembered to position it right. Good.
And then
in which case, the outer function up here would be
ln.
Yeah.
X, then blob. And your blob is going to differentiate to x plus 1. No, wait. 2x plus 1. Sorry.
Which is precisely what we had. So big deal. Job done.
Yeah.
Okay, maybe a bit of adjustment needed with this one. What do you reckon?
Okay, x squared plus 1 probably be the blob. 1 over.
Yeah.
And then you're going to get ln blob on the top, and then it's going to differentiate to 2x.
Good.
And then divide it by 2. Or times that by half.
Exactly. Bit more like that, isn't it? Are we done?
Times the top by half and plus C.
Times top by half. Plus C. If we've got if you've got minus a log, that's log of the reciprocal. What about a half of a log? Do you know another way to write a half a log of anything as a log of something?
Half a log.
Well, in general, what's the mechanical log rule that we're using here? In both cases, really. The general rule is, how do you expand log of a to the b? What's a way of rewriting log of a to the b?
Log of a to the b is a well, are we not saying there's like a third number like x?
So the power we have to raise,
it's the power you have to
base
raise
by to get the bth power of A.
Yeah.
And it's because of this rule we were referencing somewhere, we may have rubbed it out. It's because A to the B to the power of C is A to the power of BC. It's kind of because of that, although I should have used different letters, that the rule is it expands to B times log A. The power is allowed to go around the front there like that.
Right. Okay.
Okay, you might be hazy on those log rules because they need practicing all the time.
How can you just have log A? Ln A.
Well, it would mean the power we have to raise E to get A.
Oh, thinking of log. Ln. Okay.
So logs are powers of something, and you might see how it makes sense that if you're talking about the power needed to raise to get not just A, but A to the power of B, it is like we are multiplying that relevant power by B.
Yeah.
I mean, you might see that, or it might not ring true on this particular occasion. It's just so mind-bending, the log logic, and I'm rushing past it, but that's the rule. In which case, we could bring this half round to be a power, and we could say it's log of the square root of x squared plus 1, couldn't we? Power of a half.
Yeah, exactly that.
If we wanted to. A half log is fine. Just mentioning, by the way, because we'd expressed a net minus log, negative of a log, as log of reciprocal. It is the same rule, really, by which we can say half a log is log of that half power.
Right, okay. I think I understand.
Have one more? Yeah. Now, to do that one, to do number 41, you'd need to know something else. Let's do 42. I mean, it's outside the syllabus, really, number 41, I think. Kind of. Not far outside. But let's do this one quickly. Or not quickly, I'm not in a hurry. So 1 over x times log x. How shall we pass that P-A-R-S-E?
Maybe x log x is the blob, with obviously a blob inside a blob.
We are tempted to think that, aren't we? X log x could be the blob, and then we've got 1 over that, or power of minus 1. But if we do, and we say, okay, it would be log of blob, we get unwanted consequences, don't we, when we apply the chain rule here?
Yeah, probably.
Definitely, because we've got, it's a product. It's going to be quite a complicated derivative.
Oh, I see.
That's fine. We need to look at some product rule stuff as well. Tomorrow. Are we doing tomorrow? I'm fine for tomorrow if you are.
Yeah, I'm fine for tomorrow.
Good. Right. No nonsense. Good. So we would have stuff there which we'll look at tomorrow. So it can't be x log x. Can you think of another possibility instead? This is a tricky one.
So you don't think, so the blob's not log x?
Oh, it is log x, yes. Just not x log x. Did I misunderstand you the first time?
Well, the first time I actually said it would be a blob in a blob.
A blob in a blob?
Yeah.
Yeah, even so. All right. I mean, anyway, the main inside blob that we need to take account of is just log x, it turns out. What's the outside function though?
The outside function is mark to the -1.
Yes, good. Nothing to do with the x then,
Yeah, no.
because you can probably, maybe you've guessed how the x is going to be dealt with. So up here, what have we got?
We've got blob, but log
say log or
blob? Log blob.
Log blob.
And then Linux differentiates to 1 over x.
Yes, exactly. And that's how it works, you see, because you've got 1 over log x times 1 over x.
Yeah.
Because that's exactly what that is.
Of course, yeah. 1 over
log x times. But that's, you know, that's the trouble with integration. There's no clue, you know, before you've had a lot of practice. And with a lot of practice, you could fail to look at that fraction and see how it is a chain rule problem and how it, but we're completely done there, aren't we?
Yeah.
So it's log of x. You've got a composite function. Log is the outer and the inner function. We're saying log of x.
Yeah, I see.
Okay,